In our last video, we added radical expressions, but this time we're going to add some fraction radical expressions. And the first thing that you should remember about adding fractions is that you need a common denominator. And so that's how I'm going to start on this problem, is I'm going to get a common denominator of 12. So I'll multiply. That was going to be 3 here. So there's my clever 1, and there are my 4's there. And so then that's going to give me 3 radical 45 minus, and then 4 radical 5. So that when we add our fractions, we keep our denominator and we add our numerator, 3 square root of 45 minus 4 radical 5. All right, but they're not like radicals because this is a square root of 45 and the square root of 5. However, we notice that 45 is actually a product of 9 and 5, so that we can take the square root of 9, which is 3, and then get 3 times 3 is going to be 9, and then radical 5. And then minus 4 radical 5 over 12. Now we're going to subtract our coefficients, so 9 minus 4, and we're going to get 5 radical 5s over 12 for our answer. B is just a little bit different. They are still both fractions, but in this one I have the cube root of 24 over the cube root of 125. So we'll have to remember that when we have cube roots that we can separate them. I'm just going to put this next to it. That's going to be the cube root of 24 over the cube root of 125. Well, I guess first we should have observed that we can't reduce that fraction, which we can't because 5 is the only thing that goes into 125 and it doesn't go into 24. So I'm going to consider them separately now and see what we get. So we'll have the cube root of 3 over 10, and then the cube root of 24 we can simplify, and that's going to simplify. So cubes, perfect cube would be an 8. So 8 times 3. So the cube root of 8 is 2, and then we're left with the cube root of 3 inside the radical. Then the cube root of 125 is 5. So that's the first thing we'll do, is to simplify those radicals. Now I'm ready to do my addition of my fractions, and I'm going to need a common denominator of 10. So that means I'm going to multiply this one by 2 over 2. So I then will have, it's going to be equal to 3 radical, oh, this should be cube root of 3. 3 cube root of 3 over 10 plus, oh, I'm going to do 2 times 2, so that's going to be a 4. So that would be 4 cube root of 2 over, and then 2 times 5 is 10. So oh, this should have a 3 too. I'm just losing it there a little bit. So there's a cube root of 3. So now I have like radicals, cube root of 3, and so I'm going to add them. 3 plus 4 is going to be equal to 7 cube root of 3 over 10 for my answer. All right, so stop the video for a minute and give a try at this one before we look at something a little bit different. So for example 2, we're going to multiply. And the rules for multiplying radicals is that we'll multiply the coefficients and we also multiply the radicands. So this is going to look like, I'll put it in real simple terms, front times front. That's my coefficient times coefficient is going to be the inside times the inside, which is going to be my radicand times my radicand. So here, and it doesn't matter if they're alike or not, just doesn't matter. So I'm going to multiply 5 times 3 and get 15. And then inside I get 2 times 7 is 14. I'll take a minute and notice that 14 can't be simplified any further. So that's the answer. So pretty easy. So again, you'll do all the same rules as you do for regular numbers. So here I'm going to distribute. So here I have a square root of 3 times 5. So 5 is a front. It's an outside, and this is an inside. So they don't mix together. So when I multiply these two, I'm just going to have 5 on the outside, and then times radical 3 is the way that looks. And then multiply radical 3 times radical 30. So they're both inside. So I'm going to multiply them and get 90. So then I'm going to look to see if anything simplifies. Well, 90 simplifies because it's going to be a 9 times 10. So then I have 5 radical 3 plus the square root of 9 is 3 radical 10. Then I stop and look and think, can I add them? But I can't because they're not like radicals. So this then would be my final answer. So I'm going to stop the video now, and we'll pick up the next one in the next video.